Week 34. Last week, I did some UI work. I implemented the home screen. In other words, the screen that the user sees as soon as the user logs in. I would imagine that the user would spend most of their time on this screen, so I paid extra attention to make it look extra nice. Some of the examples of that extra effort were, number one, I made sure that it's responsive, right? It should look as nice on a phone in in portrait mode as it does on a tablet in landscape mode. And I would imagine that most of the users would actually use the app um, on a tablet in landscape mode. So I want to make sure that it supports that as well as, for instance, on the go on your phone in portrait mode. And the other thing is I made sure that the dark mode works. I'm not sure how important that is to, I suppose, establishments, but that's sort of the one of the telltale signs of whether or not the app is written with love. And I do want to make my app with my love. That was last week, and the UI work was done in isolation. In other words, the information that's shown on the UI is all mock data. I haven't actually hooked it up to the backend yet. So next week, I would imagine I would work on, number one, refining the UI to make it even better looking. And number two, hooking up the view models to the data layer as well as the domain layer. So that's last week and this week. But one thing I do want to talk about during this week and the things I learned from last week was the workflow that I've been using with Claude Code. So I have been relying on Claude Code for my project. And the current workflow, well, the workflow before last week was a structured single thread workflow with one agent, if you will. The way that I do it is, let's say that I wanted to implement this dashboard, and there's new libraries, and there's the new syntax of the libraries, and the way that this new library is interacting with your existing repo base. I ask Claude to perform the research for me and come up with a plan. And the thing to keep in mind with LLM it's not local, LLM AI assistants when it comes to writing code is they have a fairly large limitation surrounding the context window. An AI model can only work within the context window. Context window is essentially how much information it can hold in its brain before it just refuses to respond. For Claude Code, if you're using the Opus model, you have 128,000 tokens, roughly translating to words, not exactly, 128,000 tokens of context window. And within that context window, Claude Code can work with you to perform research, to write code. And on top of that, the Claude Code terminal enforces roughly 80% token usage before it disallows you from continuing to call the API and recommends and requires you to compact the context window, to shrink it down so that it can continue to work within the context window of the AI. This creates a lot of issues, as you can imagine, because every time you ask Claude Code to perform some research, the data that it gets from the web page, the entire page, it reads it and it keeps it in a context. And every time it generates any code in your repository, that code is in its context because that's what it generates, right? The context contains everything that it reads as well as everything that it generates. For tiny, small component, if I'm just writing one reusable UI component, that's okay. But let's say you're trying to work on an entire screen, or somehow you didn't plan correctly, and then you started the task with too big of a scope, it can run out of context more often than you think. And that's a big problem, because as soon as the context runs out, number one, it would just refuse to respond to any further requests until you compact the context. And you might ask, why don't you just compact the context and continue working? Problem with compaction is that, well, the good news is that they implemented it intelligently, or as intelligently as it can be. The way it works now in Claude Code is that when you ask it to compact the context, it reads through the entire existing context window and then tries to figure out what you're trying to do in the middle of it. And then it tries to sort of summarize and retain as much information as it thinks the next session, the next context window might need to complete your task. The problem with this is that again, it's a summarization, right? It's a smart compression, if you will, the way to think about this. And it's a lossy compression. So you lose a lot of information in that and lose a lot of context. Yeah, context. And you'll notice a fairly significant performance degradation when it comes to comprehension, adherence to the rules that you've set, as well as sort of the quality of the code output. Because again, keep in mind that in the previous context, before compaction, it has all the context with regards to the correct syntax, the correct best practice and whatnot. And then now in this compacted context, it doesn't have that. A lot of times it doesn't have that because the compaction algorithm thinks that it's extraneous information that doesn't retain it. So you'll notice a big quality jump. Sorry, a big quality drop. So in the past, what I have been doing is managing the context window, shrinking the scope, right? But it doesn't always work that neatly, particularly when, let's say, you finished the implementation and then you start writing tests and running tests, and then the tests would fail. But every time when the tests run, the log output is like gigantic, and then that all gets fed into the context window of your Claude Code, and then it jams it up and then pollutes it, and then before you know it, in the middle of your debugging, you run out of context again, and you have to compact and then lose performance again. So what's the new thing that I did last week to make it better? Subagents. And apparently subagents have been out for a month or two now. And a month or two in the AI world is an eternity. I don't know why I didn't pick it up earlier. What subagents are, on the surface, it's very straightforward. It's literally like you are talking to Claude Code. That's an agent. And then that agent can then now summon more subagents, little agents, to do its work for you. And at first, I didn't think that this would be such a big deal, but it is. It is a huge deal. And one of the biggest reasons to use this is context window preservation, right? Every subagent uses a unique new model with a fresh context window. What this means is that you can create specialized agents with Claude memory file, the instruction file, for each agent. And then in each agent, you can describe exactly what you want in the rules, the memory files, right? And then what that means is that this agent does one thing and one thing only, and it does it exceptionally well. Because every time you ask it to do something, it starts a new context window, and then it will remember the rules, because the rules are fully within the context window, and then it will perform research to do things for you, and then return the output back to the master agent. And as a result of that, I have not run into a single compaction requirement for every feature that I've implemented, because all the nuances, all the small things are actually handled by the subagents. If I wanted to debug something, to watch the log output, I would ask my debugger subagent to do that. And all the log output and the things that pertain to this particular task is there, and nothing more, nothing more. It's not going to pollute the context of the debugger with information about your intent of this implementation, because that's unnecessary. And why is it they're polluting the context and making it less efficient? So subagents are actually quite powerful, and there are a lot of because it's so new, there are so many different ways of organizing it. And so far, I'm not going to say my organization is the most efficient. I have 7 subagents, and they revolve around design, test enforcement, Git operations, and stuff like that. I've seen some other examples online with regards to how you should organize the subagents, but I tried those. I found my 7 subagents now work pretty well for me, and I'm not looking to change that anytime soon. But yeah, if you haven't done Subagents, you should give it a try. I think it'll help you a lot more than you think. It certainly did me. And one of the things is I now see a lot less "you are absolutely right" response from Claude when Claude inevitably makes some mistakes after context compaction, and then you have to correct Claude, right? And now everything is done, well, I'd say 90% of the stuff is done correctly with very little manual tweaking that I need to do. You still need to prompt correctly because the master agent needs to understand what you want to do with the subagents. And you need to, a lot of times, have to explicitly summon the subagents, like request subagents from the master agent. Otherwise, the master agent would just do it by itself. Yeah, but it's a good deal. Give it a try if you haven't, and I found it to be hugely helpful. And that's it for this week. I will see you next week.